In this video, we are going to learn how to use the quadratic formula. So, for ax squared plus bx plus c is equal to 0, the solutions are x is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. A, b, and c come from the coefficients in front of x squared, b, x, and the constant, respectively. So we're going to solve each of these equations using the quadratic formula. So in order to use it, you first need to get everything onto one side of the equation, so that's equal to 0. So I'm going to subtract 3 and get x squared plus 4x minus 3. Now, normally if I was trying to factor this, I would need to find two numbers that multiply to negative 3 but add to positive 4. But we're not going to find those numbers here, so we can't actually factor this equation. But using the quadratic formula, we have our a, which is an understood 1, our b, which is 4, and our c, which is negative 3. Now we'll go ahead and plug these values into the quadratic formula. So if x is equal to negative of b, so 4, plus or minus the square root of 4 squared, which is b, minus 4a, which is 1, and then c, which is negative 3. And its entire expression is all over 2 times the a value, which is 1. So as I go to simplify this, I will get negative 4 plus or minus the square root of 16, and then negative 4 times 1 times negative 3 is plus 12, all over 2. Now, 16 plus 12 is 28, so I'll get x is equal to negative 4 plus or minus the square root of 28 all over 2. Now, it is a very common mistake to divide 28 by 2, but it is underneath a radical. So there's no way for me to simplify any number within a radical unless I have another number within a radical, but 2 is not. But I can simplify the square root of 28, because the square root of 28 is the same as 4, square root of 4 times 7, which gives me 2 square roots of 7. So I can write this answer as x is equal to negative 4 plus or minus 2 square roots of 7 all over 2. And now I can divide each term in my numerator by 2, which gives me 2 solutions. X is equal to negative 2 plus the square root of 7, and x is equal to negative 2 minus the square root of 7 as my 2 solutions. Because we have plus or minus, so there are 2 solutions. So there they are. And since we got a square root here, that's further proof why this couldn't be factored. Because if it could have been factored, we would have gotten these square roots as parts of our answer. Now let's try to solve the other one. Here I see that my a value, because everything's already equal to 0, a is equal to negative 4. B is going to be equal to 20, and c is going to be equal to negative 25. So now as I plug this into my quadratic formula, I get x is equal to negative of 20 plus or minus the square roots of 20 squared minus 4 times a, which is negative 4, times c, which is negative 25. And this is all over 2 times a, which is negative 4. Now, as I go to simplify this, I'll get x is equal to negative 20 plus or minus the square root of 400. Here I have 3 negatives being multiplied, so I'm going to end up with a negative. And 4 times negative 4 times negative 25 would be 100 times another 4 would be negative 400. All over 2 times negative 4, which is negative 8. You'll see here I get 400 minus 400, which would be x is equal to negative 20 plus or minus the square root of 0 all over negative 8. But square root of 0 is just 0, so plus or minus doesn't mean anything in this particular situation. So I only end up with one solution, which would be each of these numbers are divisible by 4. So I can get 5 halves as my one solution. Which means that this probably could have been factored. In fact, if I would have factored out a negative here from the get-go, and I had 4x squared minus 20x plus 25, that is actually a perfect square trinomial, meaning I have negative of 2x minus 5 squared, which would lead to my answer of 5 halves. So this could have been factored, but you can still use the quadratic formula even when you can factor. Now for our last example, your school's jazz band is selling CDs as a fundraiser, and the total profit P depends on the amount X that your band charges for each CD. So the equation is P is equal to negative x squared plus 48 minus 300, and that models the profit of the fundraiser. So what is the least amount in dollars you can charge for a CD to make a profit of $200? So what this means is that I want P to equal 200. And then I'm going to solve for X to find the price that would help me get that profit of 200. So to start off, I'll move everything to one side of the equation. So I'll subtract the 200. Give me negative x squared plus 48x minus 500. And then I will plug everything into the quadratic formula. So I get x is equal to negative of 48 plus or minus the square root of 48 squared minus 4 times negative 1 times negative 500, that's A and C, all over 2 times negative 1. Now, these numbers are pretty big, but I'm going to try my best to simplify them. So I have negative 48 plus or minus the square root of 48 squared, which would be 2,304. Then I have negative 4 times negative 1 times negative 500, which is going to be a negative number, which would be 2,000. All over negative 2. So my equation here would be negative 48 plus or minus the square root of 304 all over negative 2. That does give me two solutions, which I'm going to use my calculator to calculate. So I'll put negative 48 plus the square root of 304 all divided by negative 2, which gives me approximately 15 The reason why I'm using 2 decimal places is because it's a price. And if I do it the other way, I do negative 48 minus square root of 304 divided by negative 2, I get 32.72. So that's 2 different prices I could charge to get that profit of 200, but we want to know the least amount we have to charge. So that would be $15.28. And that is how you use the quadratic formula.